Thanks to AI, creating 100
I talk to a lot of entrepreneurs and people who are building AI tools and I ask them one question. Can a solo founder build a $100 million company? And the answer surprised me a lot. The thing is, in 2025, AI becomes your co-founder, and we already see companies who make millions of dollars every month, and they are built by one person, but one person who knows how to utilize AIs. And it's not about knowing the right tool. There are a lot of tools that I'm gonna name in this video. It's about the mindset. You need to be able to explain to AI what you really need, how you need it done, and you need to make sure you are the right person to execute on your idea. So in this video, I'm gonna give you a step-by-step plan from top people in the industry on how to start your own company, being a solo founder and a solo manager of your AI automation tools. Let's dive deeper. When we talk about whether one person can build something truly massive, I want to start with a question asked Amjad Masad, the founder of Replit. He's one of those people who lives right at their intersection of creativity, code, and AI. How far ahead you think is time when a solopreneur is going to build $1 billion company?
Is it $1 billion in revenue or is it $1 billion valuation?
What's the valuation?
Valuation. So let's say...
This is $100 million in revenue.
Let's say...
It's a 10x.
Yeah, let's say 20x, so maybe a 50 million in revenue.
Okay.
I don't think it's that far. I could see it be a $50 million ARR business.
In the next couple of years?
In the next few years, yeah.
That's what's fascinating. The leverage is no longer just in capital or team size. It's in clarity. The sharper your insight into a problem, the more AI can multiply your ability to solve it. One person who deeply understands a niche could now build what once took hundreds of people.
I think it's very possible, just even watching the journey I went on with Instagram. There's a focus and an energy when you just have one or two people working on something. I think the ideal is actually two, because it's helpful having a partner when going through the ups and downs. But what I've learned is as you grow, every person you grow the team is another person that can bring their own ideas and bring their energy, which is great, but it's also another person that you need to get on board if you need to shift where the company is going. And so what I think is very exciting now is that 1, 2, 3 person team can scale themselves up, do a lot more than they would have been able to do before, maybe do it faster, and preserve that kind of, I call it conceptual integrity. Like you have like all of what matters about that company in your head or in two heads, basically working together versus trying to steer a huge ship.
When Mike said that a small team can move faster and preserve conceptual integrity, I really felt that. Because when I started my first company, LinguaTrip, it was literally just me and my husband. 2 people doing absolutely everything. We built the website, replied to every email, picked up every phone call, signed every single agreement, called every single school, negotiated with partners, ran ads, all while trying to figure out what marketing even meant, because we were first-timers. That was our first, I'll say, real job. And then I started my YouTube channel a few years later, and it was the same story again. I filmed, I edited for 6 hours, I came up with ideas, I wrote captions, made thumbnails, all by myself. It was exciting, but it was also a lot. And I always ask myself, what could I make more efficient about this process? And looking back, I think the biggest challenge wasn't the workload, it was this mental overload. You're constantly switching between being creative, being strategic, being your own manager, and sometimes you just wish you had a second version of yourself to help. And now, honestly, we kind of do. These days, I think of AI tools as my virtual co-founders. They don't replace creativity, they amplify it. And there are a few AI tools I use regularly, but one of the most powerful ones is Poppy AI. We've been loving it for months now, and what's cool about Poppy is that it's not just text. It is visual. You can upload your videos, your favorite references, transcripts, notes, even competitor examples, and it helps you see connections between your ideas. Then you can ask things like, make a reel script from this clip, turn this interview that I did into a newsletter, find the best quotes for Instagram, come up with a new topic based on these videos. It just lets you visually amplify your creative thinking. And then within minutes, it gives you structured results, saving you hours of work so you can focus on what really matters, creating and growing your business. My favorite way to do this is I take a reference post that went viral for my competitors or people that I admire, then I connect them to my draft, give my own thoughts, and ask Poppy to create a script based on what already went viral, based on that structure, using similar language, similar hooks, similar visuals. It works like magic. If I'd had something like that back when I was building my first companies, I think I would have grown not just faster, but also smarter, because I would have spent less time doing the repetitive stuff and more time thinking, okay, what's the next big idea? What actually moves the needle? Where will I get the highest ROI? So if you're at the beginning, maybe you're starting your first channel, launching a business, or just testing an idea, use tools like this early. If you decide to give Puppy AI a try, use my code SVG for $25 off the yearly plan. But honestly, the real value isn't the discount. It's that feeling of finally having more time to think, because maybe your big idea is already in front of you. You just haven't had the time to see it yet. Before you open ChatGPT or Replit and start prompting, you need clarity. Daniel Priestley calls this founder opportunity fit. It's that rare overlap between what the world needs and what you naturally love to do.
The number one strategy is pause, reflect, and document. So go for a walk with a pen and a paper. Don't listen to music. Don't take your phone if you possibly can. Your job is to go for a half an hour walk and reflect upon this question. So you want to reflect on the question, when was the last time I did something special for a certain type of person? We got a remarkable result, and I can explain how we did it step by step. Right? So you're looking to reflect on this question so that you can write down, what did we do that was special? Who did we do that for? What was the outcome? What was the result? Why was it valuable? And what were the steps that we took to get there? And it should be largely based upon something you lived through that you were hands-on with. And then you're thinking about, I wonder if I could scale that out to more people. But you're trying to find something that you enjoyed working on, because then it's going to naturally have a good founder opportunity fit.
Your best startup idea usually isn't something new. It's something you've already done successfully for someone else. It's embedded in your experience, your curiosity, your pattern recognition. It's something that your friends are asking you about. Daniel told me that's where your advantage comes from. It was the same for me. Everyone was asking me about those study abroad trips that I was doing. So when your product is built from your story, your decisions are obvious. You're not chasing trends, you're scaling something you already understand intuitively. Once you've found what you're meant to build, the next question isn't what to make, but how to make it. This is the moment where coding becomes creative writing. The founders who win won't be the ones who know syntax, they'll be the ones who know how to exactly describe what they want. So you need to understand what you want. We're always trying to build tools to optimize our internal things, and we like to use Replit for that. But when I was building something, I kept getting an error. So I asked the founder, why? I'm trying to build something with Replit right now. And the thing is, it's something that I'm encountering. So yes, it's building like a beautiful layout, but then sometimes, but see, service unavailable. That's the recent bug I got. So it feels like it's
Interesting.
Yeah.
On the deployment. So you can go to the logs here and understand why the service is unavailable. So you can see there's an error. You can copy that error and give it to the agent and tell it, when I deploy, I get this error.
Okay, let's try. But basically what I'm realizing is that it's still a little work, right?
It's work. You're still acting kind of like a software developer. You're acting like a software development manager. And so you have this powerful but easily distractible intern, and you need to manage him very well. So for example, you type this prompt, there's like only one sentence. I would have like spent maybe like another minute or two on it and just say, when I deploy the site, I'm getting this error, but I'm not getting it in the preview. And so communicating in a more precise way is very important. So prompt engineering and prompting is not that different than programming. We just take away the syntax from it, right? Like you don't have to understand the syntax and a lot of the underlying details, but you still have to be very precise. And actually it helps when communicating with developers as well to be able to talk that way.
How can I learn to be better at prompting?
We have a YouTube channel. We have a great developer relations person who creates a lot of content. His name's Matt. And so we try to train people on prompting and the underlying systems.
One of the most fascinating ideas I've heard this year is that AI is no longer your assistant, it's your collaborator. And no one understands that transition better than Mike Krieger. After scaling Instagram with just 2 people in the early days, he's now at Anthropic, where the latest version of Claude is already acting like a true co-founder. How has it changed the way you work?
For me, it's anytime I've written something, I found that I still want to take the first draft myself because sometimes writing is thinking, and that's really important that you're actually, at least for me, that I'm kind of expressing myself through writing. But before showing any human, basically anything I write that's of substance, I'll basically tell Claude and say, hey, I'm writing on this, like, what am I missing? Please challenge me on what I haven't said yet. And sometimes it'll give you a suggestion, and it ranges from, I can't believe I forgot to address that. It would have been really embarrassing to share this document and not have this. And then sometimes it's, oh, wow, I wasn't even thinking about this dimension. It's something like very new and different. And actually, I use it less for copy editing, but I use it a lot for challenging my ideas and figuring out how to, kind of understand what a very smart person looking at this would ask as the next follow-up question. And then can you kind of go from there?
Do you still type? You said you're writing, or you would do voice?
It's kind of a mix. Another thing I've done with Claude, sometimes when I'm like, I'm a little bit of writer's block, I need to get started, but I still want that experience of working through an idea myself, is I will turn on the voice mode and just talk to it for 20 minutes sometimes, and at the end say, all right, that was a lot. Now, can you organize that into some kind of, real cohesive document that you can, that I can send?
That is not full automation or replacing everyone. That's actually symbiosis. Mike is describing a new kind of teamwork where AI doesn't just respond, it initiates. It proposes, critiques, and even iterates on your behalf. The more precise you are about what success looks like, what your vibe is, I absolutely love when Mikey said that every app really has the founder's vibe, the better your AI performs.
So I was actually talking to a fellow friend who's a second or third time founder, and he was telling me, he's like, Mike, I'm really glad you launched Claude Max, because Claude is my product manager, Claude is my lawyer, Claude is my, founder therapist as well. And what he does is he has a Claude project for each of those disciplines. So he has his product manager Claude, he has his, contracts Claude, and he just uses that for all of those things. It's let him run a very lean initial company overall and do those pieces. And so even though he happens to be fairly technical, but he's not coding with Claude really in his day-to-day, he's actually set up Claude to be sort of a mini version of some of these disciplines already, even as the models, continue to get more and more powerful in those ways. Even today, with the right context and the right sort of history around something, you really can start having these sort of per job function thought partners.
That's the mindset shift. Don't think of AI as one big tool. Think of it as a set of specialists you can hire instantly. The founder's job is to design how those systems work together.
Like, if you think about the difference between the conductor in the orchestra and the people who play the instruments, the conductor knows the sound that they're trying to get to, and they know what they're trying to bring together as an overall orchestral experience. And they know what they're trying to bring to the audience, but they don't play any instruments. So I'm kind of that guy.
That's the perfect metaphor for this new era. You don't need to play every instrument anymore. You just need to know the music you're trying to create. The next natural question is, if AI can do almost anything, what should you build? To answer that, I talked to a lot of people. Actually, it's one of my favorite questions, and no one ever told me, oh yeah, just retire. Everyone is actually optimistic. So I talked to Aravind Srinivas, the founder of Perplexity. His company went from 150 million valuation 2 years ago to nearly 20 billion.
The first thing I do when I wake up is read everything all the users saying on different social platforms. A lot of people email me directly. A lot of people are messaging me on LinkedIn and Twitter. I don't have time to respond to each of these, but I make sure most of the bugs are immediately attended to. So that's kind of how I start my day, kind of waking up and fixing problems. And interestingly, that's never made me feel tired. I only get more energized by trying to fix issues. And you may think oh, what really comes out of this process of waking up every day and just bug fixing and triaging and trying to identify places for improvement. But we really believe in the mantra of 1.01 to the power 365 is 37.78.
Can you explain?
Okay, so if you do a 1% improvement every day, how much do you improve at the end of the year? You improve 3,700%.
Mm-hmm.
You don't improve like
Yeah.
1% multiplied by 365.
Yeah.
That's the concept of the exponential.
That mindset, 1% better every day, is how solo founders will build empires. You don't need a perfect plan, you need a compounding process. But even with that, Aravind says you still need obsession.
I would just say the bet you can make is do what you truly are obsessed about. Because fundamentally, it's a bet on yourself.
Mm-hmm.
It's not a bet on the market, it's not a bet on ecosystem, like what competitors will do, will not do. Like, don't try to be this whiteboard strategy master. Like, it's completely pointless. Like, when your idea works and gets like 100 million or like billion in revenue, always expect the existing people to go after it, because everyone's looking for that incremental revenue in AI because the capex is so high.
Mm-hmm.
So the only way to justify all this is to actually turn that into like business profits.
Mm-hmm.
And then so they'll go after you. So the only thing you can bet on is whether you're so obsessed about a topic that you will do it anyway, regardless of all the odds stacked against you. And then you'll prove the world wrong because you go so far deep into that, and no one cared about the problem more than you did.
Even if you build something amazing, there is a new challenge right now, discovery. Because in 2025, it's not just humans creating content and discovering products, it's AI that we use to create content, and AI recommends products. So I had to talk to someone from Google. Robbie leads AI projects at Google, and here's how he thinks a solo founder can get ahead in this world.
The AI thinks a lot like a person would in terms of the kinds of questions it issues. And so if you're a business and you're mentioned, in, top business list or from a public article that lots of people end up finding, those kinds of things become useful for the AI to find,
So
reliable
invest in your
businesses.
PR. That's something I've been hearing a lot.
So it's not really different from what you would do in that regard. I think ultimately, how else are you going to decide what business to go to? Well, you'd want to understand that.
But also, like, sometimes I invest in PR and I ask my friends, have you seen that article? And they're like, no. But then I ask AI and it really sees the article and it uses that information. So now you're investing in PR not for people to see it, but for AI.
That's actually a good way of thinking about it, because the way I mentioned before how our AI models work, they're issuing these Google searches as a tool. And so in the same way that you would optimize your website and think about how do I make helpful, clear information for people? So people search for a certain topic, my website's really helpful for that. Think of an AI doing that search now, and then knowing for that query, here are the best websites given that question. That's now will come into the context window of the model. And so when it renders a response and provides all of these links for you to go deeper, that website's more likely to show up.
Yeah.
And so it's a lot of that standard best practices around building great content really do apply in the AI age for sure.
And this is so 2025. You are no longer marketing to people, you're marketing to the algorithms that recommend things to people. So in the past, SEO was about keywords. Now it's about trust signals. If your content is genuinely useful, if your product is mentioned across quality sources, the AI will recognize you as the best match when users ask questions. So the new SEO is simple. Be helpful, be real, create content to be findable.
Have AI call. Yeah. So you can go, what kind of pet do you have? Dog. Next. Select a breed. Okay. Boom. It's a little one.
Very little, yeah, extra small.
Baby.
Under 1 year.
Bath and brush.
Haircut.
Okay, haircut.
Let's make it look like a teddy bear.
Sweet. Any flexibility?
It's okay.
Okay, flexible. You want to receive a text or an email? I guess you already got your email in here.
Yeah.
So maybe we'll just do that. Great. Los Altos. And so it puts your order in here. And so now what it's going to do is it's going to kick off a process where it's going to make phone calls on behalf of you to a bunch of different local businesses. So these are businesses that there's no easy way to access them on the web. Many of them are local. They're run by
most of
small
the businesses, right?
It's just like a person running a business.
Yeah.
And then you will get an email when it's done, and it'll give you all of the times, and you can follow up from there.
And how long is it going to take?
It depends on the
how many calls
question.
Is it going to make?
Probably 5-10 minutes. You probably get something back.
Oh, really?
Yeah.
Oh, wow. I got an email. We received your pet grooming request.
Okay, nice.
So it's working.
Okay, it's working. This one's a offline agent, so it's got to go do a bunch of phone calls for you.
That's not a demo. That's a reality. Soon AI will buy, book, and negotiate for us. The question is, can your business speak AI? That's where automation stops being a buzzword and becomes your survival strategy. There is a cool tool you can use. I talked to Mari, the founder of 11 Labs, and they're already living in that future.
There's definitely a few different areas, whether it's on the more classic customer support use cases where you, instead of having a old IVR system or no system, you can now deploy a voice agent that will take the calls instead and will both delight the customers on the other side because it understands you, it's quick, it's good, but then also just performs better. And then outside of customer support, we are seeing that across the entire lifecycle of the user journey. In some places where it adds an experience that wasn't possible before. And a simple case is inside of the product or even outside of the product. And you might have seen back in the day, there was those widgets for chat. Now you could have a voice agent that helps you navigate through the product experience. So it becomes your like a partner programmer, product person that helps you navigate through that lifecycle. And you also mentioned, so of course, some of the big pieces is in inbounding and outbounding. We actually use it ourselves in 11 Labs too, where of course we do have a standard flow. We have people that will answer the reply and take a phone call too. But if you want to go quicker, you can speak straight directly with our agent to understand our product offering, understand our pricing, understand what you can do with the product, which helps you accelerate through the pipeline, depending and sometimes self-disqualify if you are not the right fit for our product offering, and sometimes helps you accelerate, okay, this is exactly the set of use cases I can do, this is how I can deploy, and then routes it to other people.
So what does all this mean for the rest of us? For creators, for entrepreneurs, for anyone thinking about starting something now? I wanted to end this journey with a quote from Reid Hoffman, someone who's been at the center of every major tech shift over the last 20 years.
I always recommend hope versus fear, and curiosity and optimism versus paranoia. But it doesn't mean that it isn't painful to do the transition. So yes, AI tools will be available in a small number of years for everything. And there'll be AI tools for not just the thing I've created with Read AI, but like real-time interaction with Read AI and all the rest of that. And that will happen. But what we should be doing is figuring out, how do we add our own creativity? I mean, you're one of the creators and everything else. How do we add our own creativity and amplify ourselves with the tools?
I love this perspective because it matches how I see this moment. I've always been an optimist about AI, not because it's perfect, but because I see how it helps me in day-to-day life, how much my life has improved. And it opens doors that used to be locked or that were unreachable for me. The fear that it will take away our jobs is real, but the truth is it's creating a new kind of job, one where we design, direct, and collaborate with intelligence itself. And that's why I keep saying that it's very important that you work on your taste, because taste makers will be the ones who will create amazing products with AI. Thank you so much for watching this video up to the very end. And if this inspired you, share it with someone who's ready to start. Please subscribe to my email newsletter where I share my favorite AI tools that I use for my businesses. Please subscribe to this channel, and I hope to see you soon. How far ahead you think is time when a solopreneur is going to build $1 billion company?
In the next few years, yeah.
This is Amjad, founder and CEO of Replit, an AI-powered coding platform that turns your ideas into apps.
Our mission is not just to make software more accessible, but really make entrepreneurship more accessible, because creating a business is really one of the best feelings in the world.
But let's be real. Can anyone just sit down with AI and build $1 billion company? Amjad says it comes down to 3 simple steps. They turned Replit into a $3 billion business. I tried those steps myself, and what happened wasn't what I expected. Hello, everyone, and welcome to Silicon Valley Girl. We have an amazing guest today. We have Amjad, the founder of Replit. I talked about Replit a few times on this channel because I've personally been using it. And I'm just fascinated by your journey. I wanted to start with this question where you said you're going to empower 1 billion software engineers or programmers in the next couple of years. But at the same time, I saw you say that in a couple of years, companies wouldn't need software engineers. Can you explain that?
Yeah, I'm mostly talking about entrepreneurs like us. I think that bigger companies will always need software engineers, but people who have an idea, and everyone has an idea. Like, one experiment to do is just go on the street and stop people. Like, do you have a business idea? Everyone has an idea. But for the most part, the thing that's stopping them is that they don't have the technical skills, or they don't have someone, as a programmer growing up, all my friends were like, oh, hey, can you program this idea for me? Well, now you could do it. And so we're getting to a point where you can run a business. And it's difficult. It's still, the technology needs to mature. But we have a lot of stories where people have built their dream apps, and they've had these ideas for like 20 years. Mm-hmm. We're talking about a CFO at a VC firm. He's a domain expert. Like, he knows how to manage a VC fund, and he never found the right tools for him. And he had all these ideas on how to build them, but it's always hard to find engineering resources. So he used Replit, and in 3 months he built his dream app, and he went out and sold it and got a lot of contracts. And I think he made, he's on his track to make 5 million ARR, quit his job. Wow. Now he's an entrepreneur. And he told us every time he's saying, well, at some point I need to onboard a software engineer. Maybe he does, but he got to 5 million in revenue, and still he didn't have to. Yeah. I'm sure, Meta and OpenAI and us, we're always going to need software engineers, but there could be a lot more entrepreneurship in the world, a lot more businesses, if that bottleneck that is making software goes away.
Do you have like a screen here where you track your most important metric, and what's the most important metric?
So every team has a screen. Infrastructure metrics, there's like product metrics. It's really depending on the team, and almost every team has a screen.
So what's one universal metric everyone's looking at?
ARR
Okay.
is like everyone's responsibility.
Can you share your recent ARR or?
Yeah.
Yeah.
160.
160.
Yeah.
That's amazing. They've been growing like crazy. Like your graph is dream Y Combinator hockey stick.
But especially if you plot it from like 10 years.
Oh yeah, right.
And it does that.
And also like it's so encouraging for entrepreneurs who don't see progress right away.
That's right.
How many people are coding right now?
Let's see, is there about 50,000?
50,000 people?
Right here, yeah.
Do you know how many apps built on Replit are actually active and running?
Yeah, about 350,000 like paid online apps. That's growing fast. That's growing 25% month over month.
Do you know how many of them actually generate revenue?
We don't. I think those are more anecdotal, the stories that we hear. Pretty soon we're going to be helping you integrate with Stripe and monetize, so we'll be able to track that.
I think I already added my Stripe token.
So yeah, the agent knows how to do it, but we're going to make it even more effortless, like one click. Our mission is not just to make software more accessible, but really make entrepreneurship more accessible, because that's really the thing I think that changes lives the most. You can make a piece of software, it's fun, but creating a business is really one of the best feelings in the world.
Let's take a quick break. If Amjad's story with Replit fired you up and you're tired of just watching people talk about AI instead of building something real, this is your chance. HubSpot just dropped something called the 10 0 to ship vibe code prompts. It's a pick of 10 proven frameworks to help you turn a business idea into a working lead gen web app, no coding experience required. You'll get tools like Viral Hook Generator, Lead Quality Optimizer, Multi-Platform Deployment Assistant, and my favorite, the Replit Build Prompter, which acts like your own AI product manager. These prompts will help you define your perfect customer, build your prototype in Replit, generate viral hooks, names, and launch content. It will also help you benchmark your idea and plan how to turn it into a scalable growth machine. No more waiting months or spending $20K a month on a dev team. This is what building with AI actually looks like in 2025. If you're ready to launch, download the 10 0 to ship vibe code prompts for free. Link in the description. Big thanks to HubSpot for sponsoring this video. So actually, I'm trying to build something with Replit right now. And the thing is, it's something that I'm encountering. So yes, it's building like a beautiful layout, but then sometimes, see, service unavailable. That's the recent bug I got. So it feels like it's...
Interesting.
Yeah.
On the deployment. So you can go to the logs here and understand why the service is unavailable. So you can see there's an error. You can copy that error and give it to the agent and tell it, when I deploy, I get this error.
Okay, let's try. But basically what I'm realizing is that it's still a lot of work, right?
It's work.
If you have this data, how long does it take to build something that's actually working? Like what I'm trying to build here is a tool that's going to analyze my videos and let anyone analyze their videos on YouTube and determine videos that have potential if you change their title and thumbnail. You know how it works? Sometimes you repackage a video and it just starts getting all the new views. And I'm trying to build something that's going to help me do that. But I've already spent like 6 hours and it's a process.
Yeah, it is a process. You're still acting kind of like a software developer. You're acting like a software development manager. And so you have this powerful but easily distractible intern, and you need to manage him very well. So for example, you type this prompt, there's like only one sentence. I would have like spent maybe like another minute or two on it and just say, when I deploy the site, I'm getting this error, but but I'm not getting it in the preview. And so communicating in a more precise way is very important. So prompt engineering and prompting is not that different than programming. We just take away the syntax from it, right? Like you don't have to understand the syntax and a lot of the underlying details, but you still have to be very precise. And actually it helps when communicating with developers as well to be able to talk that way. So, an app like that will probably take a couple of days, whereas previously, even, a senior engineer would have taken them like a couple of weeks before AI.
$10,000, $15,000?
Yeah, something like that. It will cost you something like that. But I would spend 2-3 days on it. I think you'll be able to get it.
How can I learn to be better at prompting?
We have a YouTube channel. We have a great developer relations person who creates a lot of content. His name is Matt. And so we try to train people on prompting and the underlying systems. So Replit has a DNA in sort of education. So when we were talking about 1 billion developers, these 1 billion developers need to learn. It's not going to come for free. So there's a learning curve associated with it, and you need to be resourceful. So you need to go to YouTube, search like how to prompt. You need to spend a lot of time in practice by building, changing your style. Some people go to OpenAI, for example, and like pick O3, or right now it's GPT-5 with thinking, and give it the idea and tell it, hey, I want you to structure it into a really great prompt.
Prompt it for me, something like that.
Yeah. So I think, Paul Graham, the founder of Y Combinator, the best accelerator in the world, wrote this essay about being resourceful. And he talks about the qualities of founders. And one quality is relentlessly resourceful. So they're able to find resources to unblock themselves and be able to, not hit a wall. Because I think a lot of what entrepreneurship is finding all these walls and really driving through them. Yeah. And the way to do that is, so think of it as like a video game. in a video game, especially open world video games, you're often running into these problems where you don't know how to get to the next level. A lot of this creative thinking, kind of moving around and finding the clues, and I think entrepreneurship and building software is sort of similar to that.
Can you tell me what changed when you decided to start your company? What was this thought that was like, I need to build this?
So there's starting the project versus starting the company. Starting the project was so obvious to me. Programming is hard. We need to make programming easier. That's like a very technical sort of view on things. Starting the business was less obvious because I had worked at startups. I knew how painful they are. So I worked at Code Academy, for example, when I first came to the States. It was based on the open source version of Replit, but I saw how difficult it was, and it was really painful, a lot of hard work. So Replit was still a side project and started growing. And I didn't want to start it into a business and I actually tried to sell it to Facebook where I was working back then. I wanted to stay there. I was very comfortable and happy there. It's a scary feeling to leave your job and go heads down. But it was kind of de-risked because we had a platform that people really loved. We had 100,000 users plus a month. So after a lot of deliberation, and really trying to think what matters to you, what creates meaning in your life, and serving our customers and really achieving our mission, helping people create businesses and all of that felt very, very important. So I think it's about meaning partly.
And it feels like with this tool, there are two problems in entrepreneurship. Now it used to be three, like coming up with the idea, building the product, and marketing. Now you're left with coming up with ideas and then marketing.
Right.
What do you think is going to happen when everyone's building an app?
Yeah, so when everyone's building an app, it's still a skill, right? It's still like we talked about, it's still a skill that you can develop. And I think grit is very important. So resourcefulness, grit, like not quitting after 6 hours, like spending another day or two on it at least. I think domain knowledge is very important. So if you have excellent domain knowledge on YouTube, and so you need to give that domain knowledge into the agent. You need to prompt it in a certain way so that you're downloading your domain knowledge, and that is your competitive advantage.
But at the same time, OpenAI models are training on what I know, and then they're so much better at defining what a good YouTube video is.
I think you still have tacit knowledge that is not necessarily expressed in all your videos and all the content out there. That CFO at the VC firm has a lot of knowledge and skills he built up over the years that he can make into an app that you can't find on blogs and you can't find online. And so I think every one of us, as we go through life, we build up a lot of experiences that LLMs do not get to experience because they're not embodied.
But do you think there will ever be time when AI sees the problem, comes up with a solution, codes the app, doesn't need a human?
I might be a bit different in the Silicon Valley context in that I am quite skeptical about the AGI vision. I think we can build extremely competent agents, but you would always need the human as a driver. Because I think that the way large language models work is they train on the entire corpus of text on the internet, text in books, all of that stuff. That is text of the past, of what has happened, right? What people have put in. But can it come up with novel ideas, creative ideas based on what's changing in the world right now? Because they're not always learning. They're not continuously learning. They're within this closed box that is their training corpus, right? It's almost like a library in a very reductive way. A library has a lot of ideas, and it can remix and mix and match ideas. But a net new idea is something that I think still humans have a special place.
I love your answer, but so the fear inside me
Yeah.
wants to push back by saying that,
Please do.
all the ideas already exist in the world. Like when we're talking about new movies or new books, they take a pre-existing idea, but like changing characters, changing circumstances.
There's always a novel idea. So think about Bitcoin. Bitcoin, are you like in crypto or Bitcoin?
A little bit, yeah.
So Bitcoin, it was based on a history of 20 years people trying to build digital cash. And in the references, it's referencing Hashcash. Proof of work was existing. Proof of work, the idea that the machine is solving these cryptographic problems in order to secure the Bitcoin network was actually originally invented to fight spam. So there was the spam problem with the emails. We didn't have spam filters or AI. And so when I'm sending you an email, I solve a cryptographic problem that is expensive to show you that I'm not a spam agent, right? So Satoshi Nakamoto took all these ideas, and you're right, the existing ideas, and put them in a new package. But he added a novel idea, which is how to solve the double spend problem. And this is the blockchain, right? So I think it's easy to think about, there's nothing new under the sun. I think that's the expression. But I think if you look carefully, if you look at what Einstein did, right, like with his theories, there's always one novel insight, one really strong novel insight. It's almost like this divine intervention. There's something spiritual about having a really novel idea, and I'm sure you've experienced it in the past, that I think is fundamentally human. I don't know where it comes from.
Yeah, and also this feeling that you're the one to bring it to the world. I feel like AI likes that. Okay, let's see what's going on here. Should we go to overview and try again? No?
So hit redeploy. It's asking you to redeploy. So it'll take a second to deploy. I'd be curious. Fixed session deserialization problem. Okay.
While it's deploying, you said a gap between a Replit user and a senior Google engineer will disappear in 2 years. Should people still learn how to code, or what's going to happen to the engineering job?
I think the engineering job will continue to exist, especially in very domain-specific areas, is basically what we're talking about. There are a lot of things that are not very well represented in the data. If you're a platform engineer at Google dealing with 1 billion users, there are knowledge and things that you understand and have learned on the job that LLMs do not know because no one's written them anywhere. It's this tacit knowledge. And so I think those engineers will continue to exist. If you're an engineer at NASA and you're building fault tolerant systems, if you're building provable systems, like I don't want my Tesla autopilot to be vibe coded, right? Like there are a lot of life and death systems that we want engineers that are very low level and very almost mathematical about it to exist. So there's a lot of situations in which engineers will continue to exist. But if you're a product builder, I would say just go ahead and build the product. Like don't wait. Like if you need to learn coding along the way, learn it. But your mission is to build the thing. So I would start by building, and like we said, being resourceful along the way goes a long way.
So what should engineers who are building apps like this do now?
Let's see, where is it? There you go.
Oh, there we go. Okay, sign in. Okay, it's like
we had a new issue.
Okay, and it's like
Google authentication not configured.
Okay.
But that's how software engineers work.
Okay, this is
right?
that's
this iteration.
Okay. Got it.
Yeah.
So you
So
think
you
in
solve
2
one
days?
problem.
Yeah.
And then you get a new problem. But,
Do you think it will ever get to the stage where I don't have to do this?
Yes.
Because it could actually run
yeah.
everything and test everything.
Yes. So we.
Is that what we're working on?
Yes.
Okay. Could you talk about it, or not yet?
Usually not yet, but let me give you some hints.
Okay.
Every vibe coding platform today automates generation of code and all of that stuff, which is great, but leaves a job for you that is actually very routine and uncreative and annoying, which is quality assurance and testing.
Exactly, QA.
So we're solving that.
Okay. All right. You're launching something, right?
Mm-hmm.
Is there a lot of pressure on the team? How are they handling?
Yeah, so we have an offsite next week where we're going to be going to LA on the beach, and at least that's like a sort of a relaxing environment, and we're going to be going really deep and working really hard. And then the week after that, we're going to be coming here. It's called Sprint Week, and we do it before every launch. And people typically work 14-hour days nonstop.
You too?
Yeah.
Your wife too?
Yes.
Who takes? Okay.
So
there's a question coming from all the entrepreneurs who have kids.
Right.
Like, how do you balance this?
So there's people talk about work-life balance. We talk about work-life harmony or work-life integration. And so, for example, like we'll have the nanny bring the kids to the office. We'll have
they can vibe code.
They can vibe code. I sometimes sit down with my kid and like do a little bit of coding, but so we can see them, right? Like so. And next week for the trip, everyone here could bring their families as well. So, Replit not being super young startup, we're not that young. There's a lot of people with families. So we try to create that integration.
Do you think it works? Honestly? Or do you feel like you're missing out on your kids?
I don't feel like I'm missing out. Honestly, I don't feel like I'm missing out.
That's good.
So, just having a bit of freedom in your schedule. So I spend mornings with them. I wake up at 7, 8, and I get to the office by 10, right? But I, stay late here.
Yeah.
We have dinners here. But, I have these 2 hours in the morning at least. Sometimes I'm there for dinner as well. And on the weekend, I'll work a little bit Sunday afternoon. I'm always on my phone working, obviously, and responding and phone calls and things like that. But I feel like I'm present.
What about your wife? Similar schedule?
No, she has a less intense of a schedule. I think CEO schedule is a little more intense. And I think this is you probably can relate to that. I think being a mom, there's a more sense of guilt that I don't really
all the time.
Yeah, I don't.
Because they're
really,
back from school right now.
Right.
Yeah, but I also would love to do this.
Yeah.
Right?
Yeah. So I don't know what to speak to that, but I feel like all things considered, we feel fairly involved in their lives.
That's good. Talk to me about your mindset. You're coming up with all these new things, but at the same time, we have Lovable, Cursor, we have all of these tools. We're going to let you do the same thing. How do you see yourself being different, and how do you survive mentally as an entrepreneur?
So we're going to be the first to do what I just talked about. The
And it's
absolute
launching in
first.
September.
Yep. And last year, we're the first agent on the market. And so we're always 3, 6. I think this feature that we're building is probably going to be a year ahead of anyone else. And that's because it's built on 10 years of innovation, infrastructure innovation. Every app that you're building, every workspace is backed by a cloud virtual machine built on a file system that we innovated. We even patched the Linux kernel to make things work for Replit. And so all of that infrastructure allows us to always be ahead. We'll come up with an idea. Sometimes it takes 2, 3 months to build. If you want to build the idea from scratch, it'll take you 2, 3 years to build. And so I think Replit will actually start to diverge pretty soon. All these applications kind of look the same because they all generate a website. But when you talk to developers that are using Replit, often moved from the other platforms, they're saying that, yeah, I mean, these tools got me a pretty website pretty quickly, but a month in, I'm just blocked. It can't manage my database. I want a place to store my files. Replit ships with a database, has an object storage component, has authentication component. I know you're trying to set up Google authentication, but you can also ask the agent, implement Replit authentication, has a built-in authentication system. We built up this massive amount of infrastructure, and within the next 6 months to 12 months, I think it'll be really obvious how Replit differentiates.
Have you seen any big mistakes that people make when building something with Replit? Because I know a lot of entrepreneurs are looking and they're probably like, okay, I'll build an app, but what's next? Any tips for marketing or any lessons that you've seen along the way?
First of all, what we talked about with prompting, over-communicate. Over-communicate, be resourceful. Replit environment gives you a lot of tools like the logs and things like that. Try to over-communicate with the agent. I think that's the first tip that I would give. Even if you don't want to learn prompt engineering, just be over-communicative. And then on marketing, I think that's the next big bottleneck for entrepreneurs, right? Let's say building a product becomes easier and easier and easier. How do you go get it to market and communicate your value proposition, all of that?
Exactly. And why would someone buy something like this if they can just go to Replit and vibe code the same thing, right?
Yeah.
If it's an easy app.
There's definitely marketing is a big part of the answer. But also, like I said, domain knowledge that you have, just think about the things that you know deep in your heart of hearts that not many people in the world know. And the other thing is, like I said, grit. Just not quitting after 6 hours is very differentiating. Actually, most people just quit. And so just keep going and not quit. I've been building this business for 10 years. Before that, back in Jordan, I had this idea when I was 22, and I started working on it. Actually, there was an open source project called Replit back in 2010. And I just didn't quit. I knew it was going to big. I still know it's going to be $1 trillion company at some point in the future. Right now, we're like a $3 billion company, which is still huge.
It's amazing. Yeah. Congratulations.
Thank you. But it's just not quitting. I think a big part of it, I mean, people talk about it all the time. Just show up every day.
Yeah.
Just showing up is a big differentiator. Most people don't. Things are hard, and life is full of easy things like, you can spend 4 hours on TikTok, be endlessly entertained,
yes.
right? So that's one. On marketing, there are a few things I could say here. One is launch. Just keep launching. Go
New
launch on
products,
Reddit.
iterate. Or
Even the same product. Like make another
tweak.
Another tweak. Show it in a different way. Iterate on your messaging. Do another video. Try to reach out to influencers to partner with them.
I've seen you go on a lot of podcasts. Yeah.
Replit, I launched it 3 or 4 different times with different messaging and different things.
Interesting. So the first 3 times didn't work?
First few times it didn't work. I think when we got on Hacker News the first time, it was when I said, you can try all these different languages, and I listed the languages. Try Python, Ruby. That was before AI. And that was a hit because of the title change. And so again, it's grit, relentless resourcefulness, and just iteration.
Okay, what are your top 3 favorite AI apps? Of course, Replit.
Yeah, we'll leave that aside.
Yeah.
Perplexity. I just like going to Google and spending 5 minutes clicking on links. I can just get it really fast with Perplexity. I like to do deep research with Perplexity. So that's something I can't live without. ChatGPT. I go to Perplexity when it's like more research. I want something from the web. ChatGPT when I'm like brainstorming, and Claude and the other ones too. And let's see.
Give me something specific, like I don't know, for a specific problem. If you use anything, maybe you build your own AI agents.
Like naming products.
Yeah, Namelix, or what do you use?
No, I'm using ChatGPT.
Oh, you're using. Okay.
I like to prompt, right? Okay. I like to prompt it, and I like to kind of start different.
This is how you kind of build differently because you like prompting.
Yes.
So you just use ChatGPT for basically anything because you can prompt it.
No, I sometimes build Replit apps as well for certain things.
Oh, what did you build for yourself?
Well, recently, do you know Kindle Scribe? Mm-hmm. So, Amazon's new notebook thing, it has a web browser. Yeah. And sometimes I don't want to use my phone. My phone's somewhere else. I'm on my Kindle reading. I want to look something up. I try to open ChatGPT. It actually doesn't render because the e-ink browser kind of is like a very old school browser. So I build a ChatGPT that doesn't have any JavaScript.
Oh, okay, that's very advanced.
And it took like an hour with Replit to build. So I'm often spinning up these small tools. Anytime I find, that's the thing about Replit, it becomes addictive. Once you know that you can make certain pieces of software, you'll immediately see a problem. It's like, oh, that's shaped like a problem I could solve.
Yeah, you mentioned hard moments. Talk to me about the hardest moment building this.
Oh man, I mean, there's a bit of recency bias to this, but last year we did a layoff. And Replit culture, you'll get it from walking around. Is very positive. People really like each other here. You ask a lot of people why you're here. Some will tell you the technology, the mission. A lot of people will tell you the people. They really enjoy working with the people. And so it was very heartbreaking to have to cut the team because the business wasn't doing well. Before we launched Replit Agent, we were in this very awkward place. That's a marketing observation where we weren't good enough for the senior engineer and we weren't good enough for people like you. It wasn't easy enough. We're in the middle. So you learn how to code, use Replit a little bit, but then you graduate off of it. And so we had to add more platform features, like all the databases and things we added, but also we had to make it easier so we can have access to a larger group of people such as yourself. But at the time, we had 130 employees. We're burning money like crazy. And we had to lay off the team. And we had just actually come to this office, and this office is huge. Because I was so optimistic about our future. I knew that AI is going to be really big. I knew we're building the right thing. But we came here, we were burning all this money, and then we just had to do the layoff, and we cut the team, and I think we cut 30-40% of the team. But then a lot of people started leaving because the office is like empty. It was like a really dark place.
Was that when you were making like $2 million a year
yeah.
revenue? 2024, last
right,
year.
Last year. And you walk around here, it's very gloomy. No one's really happy. I used to come here and I was like, I can't wait to go home.
Wow.
And I think most people in our place at the time would just call it quits and try to sell the company and do something like that. But instead, the people that are working on Agent, we motivated them. We told them, we think this is the thing that's going to work. And we told them, look, if this doesn't work, there's no future. We have to make this work. And so the core team that was working on Agent, everyone stayed and worked 12, 14-hour days. And
you got to 144 million.
yes, right? In less than a year.
I heard this story that Peter Thiel passed on investing, but then you sent him your graph. Did he ever reply?
He didn't reply.
Never.
Peter Thiel invested in our Series B round in 2021. But then I went to pitch him in 2022 or 23, just before ChatGPT. I was trying to tell him, hey, AI is very important. It's going to change the nature of coding and programming. And he said, Peter Thiel is very skeptical of buzzwords. And he's known to be a contrarian. So he doesn't like anything that's popular. And so he was like, when you're saying AI, it's meaningless. It's almost like saying computers, don't come here with these buzzwords. And he basically said I was just engaging in hype. We had raised at a big valuation. I'm trying to justify that valuation. And the entire meeting, I'm trying to tell him, hey, just look at the demo. And he wouldn't look at the demo. And then I remember 4 months later, I saw him on TV talking about ChatGPT and saying, oh, it's actually a fundamental innovation. I was like, I tried to tell you. To his credit, he changed his opinion, and Founders Fund invested a big amount in Cognition, which is another agent coding company. But I did send him an email saying, after they invested in Cognition, and told him, well, I have a lot of respect for you. And that conversation was actually very hard to take in because I felt like I was doing something wrong. But I hope you can see that at the moment, I saw the future where things were headed.
And I'm glad you pushed further and built whatever you built,
yeah.
Right? Because it's so demotivating to hear things like that from people who are super respected and super smart.
Exactly. It's both demotivating, but can be motivating. It's about how you frame it, right? I've become one where I'm actually more motivated to prove doubters wrong. Haters, doubters,
You
whatever.
transform that energy into changing the world.
It's like there's nothing better than having a lot of doubters and people, naysayers, and actually proving them wrong. It's a great feeling, and I recommend it to everyone. I wish for all the entrepreneurs, I wish that you're going to have a lot of doubters, because then when you succeed, that's when the feeling comes in. Yes, I mean, if you talk to a lot of entrepreneurs, and you say, what is meaningful about your life? And they say the money's cool. Money does change your life, and it allows you more time and more resources to build and do more things. But the things that a lot of entrepreneurs kind of come back to is who they were, what they were before they created this thing. They keep remembering it was like the struggle. Everyone doubted me, but I persisted and I succeeded. And that's the best feeling in the world.
Exactly. Let's talk about the future. I have 2 small kids. And yesterday I unlocked another AI fear for me because I stumbled upon an article that said that recent graduates, just graduated from college, they're struggling to find their first jobs because there are 15% less jobs, entry-level jobs, but 30% more applications.
Yeah.
And I'm like, oh my goodness. So I'm worrying about myself and I also have to worry about my kids. What do you think about your kids' future? What are you teaching them?
Look, I think there's a deep question about where we're headed as society. What is Silicon Valley's responsibility? What is the responsibility of the government? And I think we can have hours discussion on that. I don't think anyone has a good grasp on these problems. But locally, when I'm thinking about my kids and what we're going to do in the future, I think about this idea of being more of a polymath, right? Like if you think about, even before the Industrial Revolution, the people that are most memorable, like Leonardo da Vinci, for example, did a lot of things. It was an engineer, was an artist, was all sorts of things, right? And the kind of elite education used to be about understanding a lot of things, about spending a lot of time learning about everything. And I think this is where the education needs to be headed, where the Industrial Revolution created a world where humans are treated like machines. If you think about corporations or factories, factories are one big machine, and every individual person kind of doing the assembly of one thing is a part. And I think it was very dehumanizing. And I think we're going to go back to a moment of time where there's a lot more opportunities for entrepreneurship. Even when you join a company, you're going to be judged by how much of a real business impact you're going to have, as opposed to how task-oriented you are.
But what would you say to, for example, girls, right? I have 2 girls, and the way a lot of girls are brought up are like, find a job that's sustainable, find something long-term, find something that's safe. And you're saying that everyone is basically needs to become a generalist and also an entrepreneur to generate ideas. What would you say to those women watching? How do you change your mindset?
Well, my wife is my co-founder. I think we both, Haya and I, share background of being misunderstood and being, growing up in a culture that we didn't feel like really fit our way of thinking, and we were different. And so maybe that shaped how we are and our attraction to entrepreneurship and to trying to change how people do certain things or change the world. I think there's a lot that culture imbues on sort of gender roles, but I don't think girls are fundamentally like sort of predisposed to a certain type of job. And so I think a lot of it is about upbringing and what we tell our kids and how we educate them. And so I think my advice will apply to both genders. I think that teaching them to be resourceful, actually like not hiding from them the fact that the future is very uncertain. We're in a moment of time that's very different. It's very different from when I grew up, from when your grandparents grew up or their grandparents grew up. There was a lot more certainty about the world. Right now, the world is very uncertain. And the way you're going to have to learn and the way you're going to have to adapt to this world is going to be very different. It's going to be very difficult, but we're here for you, and we're going to try to figure it out together.
How far ahead you think is time when a solopreneur is going to build $1 billion company?
Is it $1 billion in revenue or is it $1 billion valuation?
What's the valuation?
Valuation. So let's say...
So it's 100 million in revenue.
Let's say...
It's a 10x.
Yeah, let's say 20x, so maybe a 50 million in revenue.
Okay.
I don't think it's that far. Like if someone like John Chaney was able to build a 2 million, 2-3 million ARR
It's
revenue.
very niche B2B, high check. I feel like a 50 million company is a B2C company, which requires databases.
But why not? Like he has these enterprise seats. He who goes into his companies. He has a platform with a lot of content that he's selling. I could see it be a $50 million ARR business
in the next couple of years.
In the next few years, yeah. I don't see why not. But again, it's not just about the software, it's about the domain knowledge that he has.
Yeah, I love it. Thank you so much.
My pleasure.
It was amazing.
Yeah.
Great meeting
Thank you for coming.
Thank you.
At some point, you have to believe something. We've reinvented computing as we know it.
What is the vision for what you see coming next?
We asked ourselves, if it can do this, how far can it go?
How do we get from the robots that we have now to the future world that you see?
Clearly, everything that moves will be robotic someday, and it will be soon. We invested tens of billions of dollars before it really happened. No, that's very good. You did some research. But the big breakthrough, I would say, is when we...
That's Jensen Huang. And whether you know it or not, his decisions are shaping your future. He's the CEO of NVIDIA, the company that's skyrocketed over the past few years to become one of the most valuable companies in the world, because they led a fundamental shift in how computers work, unleashing this current explosion of what's possible with technology.
NVIDIA's done it again.
We found ourselves being one of the most important technology companies in the world and potentially ever.
A huge amount of the most futuristic tech that you're hearing about in AI and robotics and gaming and self-driving cars and breakthrough medical research relies on new chips and software designed by him and his company. During the dozens of background interviews that I did to prepare for this, what struck me most was how much Jensen Huang has already influenced all of our lives over the last 30 years, and how many said it's just the beginning of something even bigger. We all need to know what he's building and why, and most importantly, what he's trying to build next. Welcome to Huge Conversations. Thank you so much for doing this.
I'm so happy to do it.
Before we dive in, I wanted to tell you how this interview is going to be a little bit different than other interviews I've seen you do recently.
Okay.
I'm not going to ask you any questions about
You could ask me
company
anything you want.
finances. Thank you. I'm not going to ask you questions about your management style or why you don't like one-on-ones. I'm not going to ask you about regulations or politics. I think all of those things are important, but I think that our audience can get them well covered elsewhere.
Okay.
What we do on Huge If True is we make optimistic explainer videos. And we've covered...
God, I'm the worst person to be an explainer video.
I think you might be the best. And I think that's what I'm really hoping that we can do together is make a joint explainer video about how can we actually use technology to make the future better. Yeah. And we do it because we believe that when people see those better futures, they help build them. So the people that you're going to be talking to are awesome. They are optimists who want to build those better futures. But because we cover so many different topics, we've covered supersonic planes and quantum computers and particle colliders, it means that millions of people come into every episode without any prior knowledge whatsoever. You might be talking to an expert in their field who doesn't know the difference between a CPU and a GPU.
Yeah.
Or a 12-year-old who might grow up one day to be you, but is just starting to learn. For my part, I've now been preparing for this interview for several months. Including doing background conversations with many members of your team, but I'm not an engineer. So my goal is to help that audience see the future that you see. So I'm going to ask about 3 areas. The first is, how did we get here? What were the key insights that led to this big fundamental shift in computing that we're in now? The second is, what's actually happening right now? Well, how did those insights lead to the world that we're now living in that seems like so much is going on all at once? And the third is, what is the vision for what you see coming next? In order to talk about this big moment we're in with AI, I think we need to go back to video games in the 90s. At the time, I know game developers wanted to create more realistic-looking graphics, but the hardware couldn't keep up with all of that necessary math.
Not enough math.
NVIDIA came up with a solution that would change not just games, but computing itself. Could you take us back there and explain what was happening and what were the insights that led you and the NVIDIA team to create the first modern GPU?
So in the early 90s, when we first started the company, we observed that in a software program, inside it, there are just a few lines of code, maybe 10% of the code does 99% of the processing. And that 99% of the processing could be done in parallel. However, the other 90% of the code has to be done sequentially. It turns out that the proper computer, the perfect computer, is one that could do sequential processing and parallel processing, not just one or the other. That was the big observation. And we set out to build a company to solve computer problems that normal computers can't. And that's really the beginning of NVIDIA.
My favorite visual of why a CPU versus a GPU really matters so much is a 15-year-old video on the NVIDIA YouTube channel, where the Mythbusters, they use a little robot shooting paintballs one by one to show solving problems one at a time, or sequential processing on a CPU. But then they roll out this huge robot that shoots all of the paintballs at once, doing smaller problems all at the same time, or parallel processing on a GPU.
3, 2, 1.
So NVIDIA unlocks all of this new power for video games. Why gaming first?
The video games requires parallel processing for processing 3D graphics. And we chose video games because, one, we loved the application. It's a simulation of virtual worlds, and who doesn't want to go to virtual worlds? And we had the good observation that video games has potential to be the largest market for entertainment ever. And it turned out to be true. And having it being a large market is important because the technology is complicated. And if we had a large market, our R&D budget could be large. We could create new technology. And that flywheel between technology and market and greater technology was really the flywheel that got NVIDIA to become one of the most important technology companies in the world. And it was all because of video games.
I've heard you say that GPUs were a time machine.
Yeah.
Could you tell me more about what you meant by that?
A GPU is like a time machine because it lets you see the future sooner. One of the most amazing things anybody's ever said to me was a quantum chemistry scientist. He said, Jensen, because of NVIDIA's work, I can do my life's work in my lifetime. That's time travel. He was able to do something that was beyond his lifetime, within his lifetime. And that's because we make applications run so much faster. And so you get to see the future. And so when you're doing weather prediction, for example, you're seeing the future. When you're doing a simulation, a virtual city with virtual traffic, and we're simulating our self-driving car through that virtual city, we're doing time travel.
So parallel processing takes off in gaming, and it's allowing us to create worlds in computers that we never could have before. And gaming is sort of this first incredible case of parallel processing unlocking a lot more power. And then, as you said, people begin to use that power across many different industries. The case of the quantum chemistry researcher. When I've heard you tell that story, it's that he was running molecular simulations in a way where it was much faster to run in parallel on NVIDIA GPUs, even then, than it was to run them on the supercomputer with the CPU that he had been using before.
Yeah, that's true.
So, oh my God, it's revolutionizing all of these other industries as well. It's beginning to change how we see what's possible with computers. And my understanding is that in the early 2000s, you see this, and you realize that actually doing that is a little bit difficult, because what that researcher had to do is he had to sort of trick the GPUs into thinking that his problem was a graphics problem.
That's exactly right. No, that's very good. Well,
So you
did some research.
So you create a way to make that a lot easier.
That's right.
Specifically, it's a platform called CUDA, which lets programmers tell the GPU what to do using programming languages that they already know, like C. And that's a big deal because it gives way more people easier access to all of this computing power. Could you explain what the vision was that led you to create CUDA?
Partly researchers discovering it, partly internal inspiration, and partly solving a problem. And a lot of interesting ideas come out of that soup. Some of it is aspiration and inspiration. Some of it is just desperation. And so in the case of CUDA, it was very much the same way. And probably the first external ideas of using our GPUs for parallel processing emerged out of some interesting work in medical imaging. A couple of researchers at Mass General were using it to do CT reconstruction. They were using our graphics processors for that reason, and it inspired us. Meanwhile, the problem that we're trying to solve inside our company has to do with the fact that when you're trying to create these virtual worlds for video games, you would like it to be beautiful, but also dynamic. Water should flow like water, and explosions should be like explosions. So there's particle physics you want to do, fluid dynamics you want to do, and that is much harder to do if your pipeline is only able to do computer graphics. And so we have a natural reason to want to do it in the market that we were serving. So researchers were also horsing around with using our GPUs for general purpose acceleration. And so there are multiple factors that were coming together in that soup. When the time came, and we decided to do something proper and create a CUDA as a result of that. Fundamentally, the reason why I was certain that CUDA was going to be successful, and we put the whole company behind it, was because fundamentally, our GPU was going to be the highest volume parallel processors built in the world because the market of video games was so large. And so this architecture has a good chance of reaching many people.
It has seemed to me like creating CUDA was this incredibly optimistic, huge if true thing to do, where you were saying, if we create a way for many more people to use much more computing power, they might create incredible things. And then, of course, it came true. They did. In 2012, a group of 3 researchers submits an entry to a famous competition where the goal is to create computer systems that could recognize images and label them with categories. And their entry just crushes the competition. It gets way fewer answers wrong. It was incredible. It blows everyone away. It's called AlexNet, and it's a kind of AI called a neural network. My understanding is one reason it was so good is that they used a huge amount of data to train that system. And they did it on NVIDIA GPUs. All of a sudden, GPUs weren't just a way to make computers faster and more efficient. They're becoming the engines of a whole new way of computing. We're moving from instructing computers with step-by-step directions to training computers to learn by showing them a huge number of examples. This moment in 2012 really kicked off this truly seismic shift that we're all seeing with AI right now. Could you describe what that moment was like from your perspective? And what did you see it would mean for all of our futures?
When you create something new like CUDA, if you build it, they might not come. And that's always the cynic's perspective. However, the optimist perspective would say, but if you don't build it, they can't come. And that's usually how we look at the world. You know, we have to reason about intuitively why this would be very useful. And in fact, in 2012, Ilya Sutskever and Alex Krzyzewski and Jeff Hinton in the University of Toronto, the lab that they were at, they reached out to a GeForce GTX 580 because they learned about CUDA and that CUDA might be able to be used as a parallel processor for training AlexNet. And so our inspiration that GeForce could be the vehicle to bring out this parallel architecture into the world, and that researchers would somehow find it someday was a good strategy. It was a strategy based on hope, but it was also reasoned hope. The thing that really caught our attention was simultaneously we were trying to solve the computer vision problem inside the company, and we were trying to get CUDA to be a good computer vision processor. And we were frustrated by a whole bunch of early developments internally with respect to our computer vision effort and getting CUDA to be able to do it. And all of a sudden, we saw AlexNet, this new algorithm that is completely different than computer vision algorithms before it, take a giant leap in terms of capability for computer vision. And when we saw that, it was partly out of interest, but partly because we were struggling with something ourselves. And so we were highly interested to want to see it work. And so when we looked at AlexNet, we were inspired by that. But the big breakthrough, I would say, is when we saw AlexNet, we asked ourselves, you know, how far can AlexNet go? If it can do this with computer vision, how far can it go? And if it could go to the limits of what we think it could go, the type of problems it could solve, what would it mean for the computer industry, and what would it mean for the computer architecture? And we rightfully reasoned that if machine learning, if deep learning architecture can scale, the vast majority of machine learning problems could be represented with deep neural networks. And the type of problems we could solve with machine learning is so vast that it has the potential of reshaping the computer industry altogether, and which prompted us to re-engineer the entire computing stack, which is where DGX came from, and this little baby DGX sitting here. All of this came from that observation that we ought to reinvent the entire computing stack layer by layer by layer. Computers, after 65 years since IBM System 360 introduced modern general purpose computing, we've reinvented computing as we know it.
To think about this as a whole story. So parallel processing reinvents modern gaming and revolutionizes an entire industry. Then that way of computing, that parallel processing, begins to be used across different industries. You invest in that by building CUDA, and then CUDA and the use of GPUs allows for a step change in neural networks and machine learning and begins a sort of revolution that we're now seeing only increase in importance today.
All of a sudden, computer vision is solved. All of a sudden, speech recognition is solved. All of a sudden, language understanding is solved. These incredible problems associated with intelligence, one by one by one by one, where we had no solutions for in the past, desperate desire to have solutions for, all of a sudden, one after another gets solved, every couple of years. It's incredible.
Yeah, so you're seeing that in 2012. You're looking ahead and believing that that's the future that you're going to be living in now. And you're making bets that get you there, really big bets that have very high stakes. And then my perception as a layperson is that it takes a pretty long time to get there. You make these bets.
10 years.
So my question is, if AlexNet happened in 2012, and this audience is probably seeing and hearing so much more about AI and NVIDIA specifically 10 years later, why did it take a decade? And also, because you had placed those bets, what did the middle of that decade feel like for you?
Well, that's a good question. It probably felt like today. To me, there's always some problem, and then there's some reason to be impatient. There's always some reason to be happy about where you are, and there's always many reasons to carry on. And so I think as I was reflecting a second ago, that sounds like this morning. But I would say that in all things that we pursue, first you have to have core beliefs. You have to reason from your best principles. And ideally, you're reasoning from principles of either physics or deep understanding of the industry or deep understanding of the science, wherever you're reasoning from. You reason from first principles, and at some point you have to believe something. And if those principles don't change and the assumptions don't change, then there's no reason to change your core beliefs. And then along the way, there's always some evidence of success and that you're leading in the right direction. And sometimes you go a long time without evidence of success, and you might have to course correct a little. But the evidence comes, and if you feel like you're going in the right direction, we just keep on going. The question of why did we stay so committed for so long? The answer is actually the opposite. There was no reason to not be committed because we believed it. And I've believed in NVIDIA for 30 plus years, and I'm still here working every single day. And there's no fundamental reason for me to change my belief system. And I fundamentally believe that the work we're doing in revolutionizing computing is as true today, even more true today than it was before. And so we'll stick with it, until otherwise. There's, of course, very difficult times along the way. When you're investing in something and nobody else believes in it and costs a lot of money, and maybe investors or others would rather you just keep the profit or whatever it is, improve the share price or whatever it is. But you have to believe in your future. You have to invest in yourself, and we believed it so deeply that we invested tens of billions of dollars before it really happened. And it was 10 long years, but it was fun along the way.
How would you summarize those core beliefs? What is it that you believe about the way computers should work and what they can do for us that keeps you not only coming through that decade, but also doing what you're doing now, making bets I'm sure you're making for the next few decades?
The first core belief was our first discussion was about accelerated computing, parallel computing versus general purpose computing. We would add two of those processors together, and we would do accelerated computing. And I continue to believe that today. The second was the recognition that these deep learning networks, these DNNs that came to the public during 2012, these deep neural networks have the ability to learn patterns and relationships from a whole bunch of different types of data, and that it can learn more and more nuanced features if it could be larger and larger. And it's easier to make them larger and larger, just make them deeper and deeper, or wider and wider. And so the scalability of the architecture is empirically true. The fact that model size and the data size being larger and larger, you can learn more knowledge, is also true, empirically true. And so if that's the case, you could, what are the limits? There's not, unless there's a physical limit or an architectural limit or a mathematical limit, and it was never found. And so we believe that you could scale it. Then the only other question is, what can you learn from data? What can you learn from experience? Data is basically digital versions of human experience. And so what can you learn? You obviously can learn object recognition from images. You can learn speech from just listening to sound. You can learn even languages and vocabulary and syntax and grammar, and all just by studying a whole bunch of letters and words. So we've now demonstrated that AI or deep learning has the ability to learn almost any modality of data, and it can translate to any modality of data. And so what does that mean? You can go from text to text, right? Summarize a paragraph. You can go from text to text, translate from language to language. You can go from text to images, that's image generation. You can go from images to text, that's captioning. You can even go from amino acid sequences to protein structures. In the future, you'll go from protein to words. What does this protein do? Or give me an example of a protein that has these properties, identifying a drug target. And so you could just see that all of these problems are around the corner to be solved. You can go from words to video. Why can't you go from words to action tokens for a robot? Mm-hmm. From the computer's perspective, how is it any different? And so it opened up this universe of opportunities and universe of problems that we can go solve. And that gets us quite excited.
It feels like we are on the cusp of this truly enormous change. When I think about the next 10 years, unlike the last 10 years, I know we've gone through a lot of change already, but I don't think I can predict anymore how I will be using the technology that is currently being developed.
That's exactly right. I think the reason why you feel that way is the last 10 years was really about the science of AI. The next 10 years, we're going to have plenty of science of AI, but the next 10 years is going to be the application science of AI, the fundamental science versus the application science. And so the applied research, the application side of AI now becomes, how can I apply AI to digital biology? How can I apply AI to climate technology? How can I apply AI to agriculture, to fishery, to robotics, to transportation, optimizing logistics? How can I apply AI to, teaching? How do I apply AI to, podcasting, right? And so
I'd love to choose a couple of those to help people see how this fundamental change in computing that we've been talking about is actually going to change their experience of their lives, how they're actually going to use technology that is based on everything we just talked about. One of the things that I've now heard you talk a lot about and I have a particular interest in is physical AI, or in other words, robots.
My friends.
Meaning humanoid robots, but also robots like self-driving cars and smart buildings or autonomous warehouses or autonomous lawnmowers or more. From what I understand, we might be about to see a huge leap in what all of these robots are capable of, because we're changing how we train them. Up until recently, you've either had to train your robot in the real world, where it could get damaged or wear down, or you could get data from fairly limited sources like humans in motion capture suits. But that means that robots aren't getting as many examples as they'd need to learn more quickly. But now, We're starting to train robots in digital worlds, which means way more repetitions a day, way more conditions, learning way faster. So we could be in a big bang moment for robots right now. And NVIDIA is building tools to make that happen. You have Omniverse, and my understanding is this is 3D worlds that help train robotic systems so that they don't need to train in the physical world.
That's exactly right.
You just announced Cosmos, which is ways to make that 3D universe much more realistic. So you can get all kinds of different, if we're training something on this table, many different kinds of lighting on the table, many different times of day, many different, experiences for the robot to go through so that it can get even more out of Omniverse. As a kid who grew up loving data on Star Trek, Isaac Asimov's books, and just dreaming about a future with robots, how do we get from the robots that we have now to the future world that you see of robotics?
Yeah. Let me use language models, maybe ChatGPT, as a reference for understanding Omniverse and Cosmos. And so first of all, when ChatGPT first came out, it was extraordinary, and it has the ability to do to basically from your prompt generate text. However, as amazing as it was, it has the tendency to hallucinate if it goes on too long, or if it pontificates about a topic it is not informed about. It'll still do a good job generating plausible answers. It just wasn't grounded into truth, and so people called it hallucination. And so the next generation, shortly, it had the ability to be conditioned by context. So you could upload your PDF, and now it's grounded by the PDF. The PDF becomes the ground truth. It could actually look up search, and then the search becomes its ground truth. And between that, it could reason about how to produce the answer that you're asking for. And so the first part is a generative AI, and the second part is ground truth. Okay, and so now let's come into the physical world, the world model. We need a foundation model, just like we need ChatGPT had a core foundation model. That was the breakthrough. In order for robotics to be smart about the physical world, it has to understand things like gravity, friction, inertia, geometric and spatial awareness. It has to understand that an object is sitting there even when I looked away. When I come back, it's still sitting there, object permanence. It has to understand cause and effect. If I tip it, it'll fall over. And so these kind of physical common sense, if you will, has to be captured or encoded into a world foundation model so that the AI has world common sense. Okay? And so somebody has to go create that, and that's what we did with Cosmos. We created a world language model. Just like ChatGPT was a language model, this is a world model. The second thing we have to go do is we have to do the same thing that we did with PDFs and context and grounding it with ground truth. And so the way we augment Cosmos with ground truth is with physical simulations, because Omniverse uses physics simulation, which is based on principled solvers. The mathematics is Newtonian physics. It's the math we know. Okay, all of the fundamental laws of physics we've understood for a very long time, and it's captured into Omniverse. That's why Omniverse is a simulator. And using the simulator to ground or to condition Cosmos, we can now generate an infinite number of stories of the future, and they're grounded on physical truth. Just like between PDF or search plus ChatGPT, we can generate an infinite amount of interesting things, answer a whole bunch of interesting questions. The combination of Omniverse plus Cosmos, you could do that for the physical world.
So to illustrate this for the audience, if you had a robot in a factory and you wanted to make it learn every route that it could take, instead of manually going through all of those routes, which could take days and could be a lot of wear and tear on the robot, we're now able to simulate all of them digitally in a fraction of the time, and in many different situations that the robot might face. It's dark, it's blocked, it's etc. So the robot is now learning much, much faster. It seems to me like the future might look very different than today. If you play this out 10 years, how do you see people actually interacting with this technology in the near future?
Cleo, everything that moves will be robotic someday, and it will be soon. You know, the idea that we'll be pushing around a lawnmower is already kind of silly. You know, maybe people do it because it's fun, but there's no need to. And every car is going to be robotic. Humanoid robots, the technology necessary to make it possible is just around the corner. And so everything that moves will be robotic. And they'll learn how to be a robot in Omniverse Cosmos, and will generate all these physically plausible futures, and the robots will learn from them, and then they'll come into the physical world, and you know, it's exactly the same. A future where you're just surrounded by robots is for certain, and I'm just excited about having my own R2D2. And of course, R2D2 wouldn't be quite the can that it is and roll around. It'll be a, you know, R2D2. Yeah, it'll probably be a different physical embodiment, but it's always R2. You know, so my R2 is going to go around with me. Sometimes it's in my smart glasses. Sometimes it's in my phone. Sometimes it's in my PC. It's in my car. So R2 is with me all the time, including, you know, when I get home, you know, where I left a physical version of R2, and you know, whatever that version happens to be, you know, we'll interact with R2. And so I think the idea that we'll have our own R2D2 for our entire life, and it grows up with us, that's a certainty now. Yeah.
I think a lot of news media, when they talk about futures like this, they focus on what could go wrong. And that makes sense.
Yeah.
There is a lot that could go wrong.
Yeah. We should talk about what could go wrong so we can keep it from
yes,
going wrong. Yeah.
That's the approach that we like to take on the show is what are the big challenges so that we can overcome them?
Yeah.
What buckets do you think about when you're worrying about this future?
Well, there's a whole bunch of the stuff that everybody talks about, bias or toxicity or just hallucination. You know, speaking with great confidence about something it knows nothing about. And as a result, we rely on that information. Generating, that's a version of generating fake information, fake news or fake images or whatever it is. Of course, impersonation. It does such a good job pretending to be a human. It could do an incredibly good job pretending to be a specific human. And so the spectrum of areas that we have to be concerned about is fairly clear, and there's a lot of people who are working on it. There's some of the stuff related to AI safety requires deep research and deep engineering, and that's simply it wants to do the right thing, it just didn't perform it right, and as a result hurt somebody. You know, for example, a self-driving car that wants to drive nicely and drive properly, and just somehow the sensor broke down or it didn't detect something, or you know, made it too aggressive turn or whatever it is. It did it poorly. It did it wrongly. And so that's a whole bunch of engineering that has to be done to make sure that AI safety is upheld by making sure that the product functioned properly. And then lastly, you know, what happens if the AI wants to do a good job, but the system failed? Meaning the AI wanted to stop something from happening, and it turned out just when it wanted to do it, the machine broke down. And so this is no different than a flight computer inside a plane having 3 versions of them, and then so there's triple redundancy inside the system, inside autopilots, and then you have 2 pilots. And then you have air traffic control, and then you have other pilots watching out for these pilots. And so the AI safety systems has to be architected as a community such that these AIs, function properly. When they don't function properly, they don't put people in harm's way, and that there's sufficiently safety and security systems all around them to make sure that we keep AI safe. And so there's the spectrum of conversation is gigantic, and we have to take the parts apart and build them as engineers.
One of the incredible things about this moment that we're in right now is that we no longer have a lot of the technological limits that we had in a world of CPUs and sequential processing, and we've unlocked not only a new way to do computing but also a way to continue to improve. Parallel processing has a different kind of physics to it than the improvements that we were able to make on CPUs. I'm curious, what are the scientific or technological limitations that we face now in the current world that you're thinking a lot about?
Well, everything in the end is about how much work you can get done within the limitations of the energy that you have. And so that's a physical limit. And the laws of physics about transporting information and transporting bits, flipping bits and transporting bits, at the end of the day, the energy it takes to do that limits what we can get done. And the amount of energy that we have limits what we can get done. We're far from having any fundamental limits that keep us from advancing. In the meantime, we seek to build better, more energy efficient computers. This little computer, the big version of it was $250,000.
Can I pick it up?
Yeah. That's little baby digits. Yeah. This is an AI supercomputer. The version that I delivered, this is just a prototype, so it's a mock-up. And so the very first version was DGX-1. I delivered to OpenAI in 2016, and that was $250,000, 10,000 times more power, more energy necessary than this version. And this version has 6 times more performance. I know, it's incredible.
We're in a whole new world.
And it's only since 2016. And so 8 years later, we've increased the energy efficiency of computing by 10,000 times. And imagine if we became 10,000 times more energy efficient, or if a car was 10,000 times more energy efficient, or electric light bulb was 10,000 times more energy efficient. Our light bulb would be right now, instead of 100 watts, 10,000 times less, producing the same illumination. Yeah, and so the energy efficiency of computing, particularly for AI computing that we've been working on, has advanced incredibly, and that's essential because we want to create more intelligent systems, and we want to use more computation to be smarter, and so energy efficiency to do the work is our number one priority.
When I was preparing for this interview, I spoke to a lot of my engineering friends, and this is a question that they really wanted me to ask. So you're really speaking to your people here. You've shown a value of increasing accessibility and abstraction with CUDA and allowing more people to use more computing power in all kinds of other ways. As applications of technology get more specific, I'm thinking of transformers in AI, for example. For the audience, a transformer is a very popular, more recent structure of AI that's now used in a huge number of the tools that you've seen. The reason that they're popular is because transformers are structured in a way that helps them pay attention to key bits of information and give much better results. You could build chips that are perfectly suited for just one kind of AI model. But if you do that, then you're making them less able to do other things. So as these specific structures or architectures of AI get more popular, my understanding is there's a debate between how much you place these bets on burning them into the chip or designing hardware that is very specific to a certain task versus staying more general. And so my question is, how do you make those bets? How do you think about whether the solution is a car that could go anywhere, or it's really optimizing a train to go from A to B? You're making bets with huge stakes, and I'm curious how you think about that.
Yeah, and that now comes back to exactly your question: what are your core beliefs? And the question, the core belief, either one, that transformer is the last AI algorithm, AI architecture that any researcher will ever discover again, or that Transformers is a stepping stone towards evolutions of Transformers that are barely recognizable as a Transformer years from now. And we believe the latter. And the reason for that is because you just have to go back in history and ask yourself, in the world of computer algorithms, in the world of software, in the world of engineering and innovation, has one idea stayed along that long? And the answer is no. And so that's kind of the beauty. That's in fact the essential beauty of a computer, that it's able to do something today that no one even imagined possible 10 years ago. And if you were to turn that computer 10 years ago into a microwave, then why would the applications keep coming? And so we believe in the richness of innovation and the richness of invention, and we want to create an architecture that let inventors and innovators and software programmers and AI researchers swim in the soup and come up with some amazing ideas. Look at transformers. The fundamental characteristic of a transformer is this idea called attention mechanism. And it basically says the transformer is going to understand the meaning and the relevance of every single word with every other word. So if you had 10 words, it has to figure out the relationship across 10 of them. But if you have 100,000 words, or if your context is now as large as read a PDF and read a whole bunch of PDFs, and the context window is now like 1 million tokens, processing all of it across all of it is just impossible. And so the way you solve that problem is there are all kinds of new ideas, flash attention or hierarchical attention, or all the wave attention I just read about the other day. The number of different types of attention mechanisms that have been invented since the transformer is quite extraordinary. And so I think that that's going to continue, and we believe it's going to continue, and that computer science hasn't ended, and that AI research have not all given up, and we haven't given up anyhow, and that having a computer that enables the flexibility of research and innovation and new ideas is fundamentally the most important thing.
One of the things that I am just so curious about, you design the chips. There are companies that assemble the chips. There are companies that design hardware to make it possible to work at nanometer scale. When you're designing tools like this, how do you think about design in the context of what's physically possible right now to make? What are the things that you're thinking about with sort of pushing that limit today?
The way we do it is, even though we have things made, like for example, our chips are made by TSMC. Even though we have them made by TSMC, we assume that we need to have the deep expertise that TSMC has. And so we have people in our company who are incredibly good at semiconductor physics, so that we have a feeling for, we have an intuition for what are the limits of what today's semiconductor physics can do. And then we work very closely with them to discover the limits, because we're trying to push the limits. And so we'll discover the limits together. We do the same thing in system engineering and cooling systems. It turns out plumbing is really important to us because of liquid cooling, and maybe fans are really important to us because of air cooling. And we're trying to design these fans in a way almost like, they're aerodynamically sound, so that we could pass the highest volume of air, make the least amount of noise. So we have aerodynamics engineers in our company. And so even though we don't make them, we design them, and we have the deep expertise of knowing how to have them made. And from that, we try to push the limits.
One of the themes of this conversation is that you are a person who makes big bets on the future. And time again, you've been right about those bets. We've talked about GPUs, we've talked about CUDA, we've talked about bets you've made in AI.
Self-driving cars, and we're going to be right on robotics. And
this is my question.
Yeah,
what are the bets that you're making now?
Omniverse. The latest bet, of course, we just described at the CES, and I'm very, very proud of it, and I'm very excited about it, is the fusion of Omniverse and Cosmos, so that we have this new type of generative world generation system, this multiverse generation system. I think that's going to be profoundly important in the future of robotics and physical systems. Of course, the work that we're doing with humanoid robots, developing the tooling systems and the training systems and the human demonstration systems and all of this stuff that you've already mentioned, we're just seeing the beginnings of that work. And I think the next 5 years are going to be very interesting in the world of humanoid robotics. Of course, the work that we're doing in digital biology so that we can understand the language of molecules and understand the language of cells, and just as we understand the language of physics and the physical world, we'd like to understand the language of the human body and understand the language of biology. And so if we can learn that and we can predict it, then all of a sudden our ability to have a digital twin of the human is plausible. And so I'm very excited about that work. I love the work that we're doing in climate science and be able to, from weather predictions, understand and predict the high resolution regional climates, the weather patterns within a kilometer above your head, that we can somehow predict that with great accuracy. Its implications is really quite profound. And so the number of things that we're working on is really cool. You know, we're fortunate that we've created this instrument that is a time machine, and we need time machines in all of these areas that we just talked about, so that we can see the future. And if we could see the future and we can predict the future, then we have a better chance of making that future the best version of it. And that's the reason why scientists want to predict the future. That's the reason why we try to predict the future in everything that we try to design, so that we can optimize for the best version.
So if someone is watching this and maybe they came into this video knowing that NVIDIA is an incredibly important company, but not fully understanding why or how it might affect their life, and they're now hopefully better understanding a big shift that we've gone through over the last few decades in computing, this very exciting, very sort of strange moment that we're in right now where we're sort of on the precipice of so many different things. If they would like to be able to look into the future a little bit, how would you advise them to prepare or to think about this moment that they're in personally with respect to how these tools are actually going to affect them?
Well, there are several ways to reason about the future that we're creating. One way to reason about it is, suppose the work that you do continues to be important, but the effort by which you do it went from being a week long to almost instantaneous. That the effort of drudgery basically goes to zero. What is the implication of that? This is very similar to what would change if all of a sudden we had highways in this country, and that kind of happened. In the last industrial revolution, all of a sudden we have interstate highways, and when you have interstate highways, what happens? Well, suburbs start to be created, and all of a sudden, distribution of goods from east to west is no longer a concern, and all of a sudden gas stations start cropping up on highways, and fast food restaurants show up, and some motels show up because people traveling across the state, across the country, just wanted to stay somewhere for a few hours or overnight, and so all of a sudden new economies and new capabilities, new economies. What would happen if video conference made it possible for us to see each other without having to travel anymore? That all of a sudden it's actually okay to work further away from home and from work and live further away, and so you ask yourself kind of these questions. What would happen if I have a software programmer with me all the time, and whatever it is I can dream up, the software programmer could write for me. What would that do? What would happen if if I just had a seed of an idea and I rough it out, and all of a sudden a prototype of a production was put in front of me, and how would that change my life, and how would that change my opportunity, and what does it free me to be able to do, and so on and so forth. And so I think that the next decade, intelligence, not for everything, but for some things, would basically become superhuman. And so I can tell you exactly what that feels like. I'm surrounded by superhuman people, super intelligence from my perspective, because they're the best in the world at what they do. And they do what they do way better than I can do it. And I'm surrounded by thousands of them. And yet, it never one day caused me to think all of a sudden I'm no longer necessary. It actually empowers me and gives me the confidence to go tackle more and more ambitious things. And so suppose now everybody is surrounded by these super AIs that are very good at specific things, or good at some of the things. What would that make you feel? Well, it's going to empower you. It's going to make you feel confident. And I'm pretty sure you probably use ChatGPT and AI, and I feel more empowered today, more confident to learn something today. The knowledge of almost any particular field, the barriers to that understanding it has been reduced. And I have a personal tutor with me all of the time, and so I think that feeling should be universal. And if there's one thing that I would encourage everybody to do, is to go get yourself an AI tutor right away. And that AI tutor could, of course, just teach you things, anything you like, help you program, help you write, help you analyze, help you think, help you reason. All of those things is going to really make you feel empowered. And I think that's going to be our future. We're going to become superhumans. Not because we have we're going to become superhumans because we have super AIs.
Could you tell us a little bit about each of these objects?
This is a new GeForce graphics card. And yes. And this is the RTX 50 series. It is essentially a supercomputer that you put into your PC. And we use it for gaming. Of course, people today use it for design and creative arts, and it does amazing AI. And the real breakthrough here, and this is truly an amazing thing. GeForce enabled AI, and it enabled Jeff Hinton, Elias Escobar, and Alex Krzyzewski to be able to train AlexNet. We discovered AI, and we advanced AI. Then AI came back to GeForce to help computer graphics. And so here's the amazing thing. Out of 8 million pixels or so in a 4K display, we're processing only 500,000 of them. The rest of them, we use AI to predict. The AI guessed it. And yet the image is perfect. We inform it by the 500,000 pixels that we computed, and we ray traced every single one, and it's all beautiful, it's perfect. And then we tell the AI, if these are the 500,000 perfect pixels in the screen, what are the other 8 million? And it fills in the rest of the screen, and it's perfect.
And if you only have to do fewer pixels, are you able to invest more in doing that because you have fewer to do, so then the quality is better, so the extrapolation that the AI does is better?
Exactly, because whatever attention you have, whatever resources you have, you can place it into 500,000 pixels. Now, this is a perfect example of why AI is going to make us all superhuman. Because all of the other things that it can do, it'll do for us, allows us to take our time and energy and focus it on the really, really valuable things that we do. And so we'll take our own resource, which is, energy intensive, attention intensive, and we'll dedicate it to the few 100,000 pixels and use AI to super res it, up res it, to everything else. And so this graphics card is now powered mostly by AI. And the computer graphics technology inside is incredible as well. And then this next one, as I mentioned earlier, in 2016, I built the first one for AI researchers, and we delivered the first one to OpenAI. And Elon was there to receive it. And this version, I built a mini version. And the reason for that is because AI has now gone from AI researchers to every engineer, every student, every AI scientist. And AI is going to be everywhere. And so instead of these $250,000 versions, we're going to make these $3,000 versions. And schools can have them, students can have them. And you set it next to your PC or Mac. And all of a sudden, you have your own AI supercomputer. And you develop and build AIs, build your own AI, build your own R2D2.
What do you feel like is important for this audience to know that I haven't asked?
One of the most important things I would advise is, for example, if I were a student today, the first thing I would do is to learn AI. How do I learn to interact with ChatGPT? How do I learn to interact with Gemini Pro? And how do I learn to interact with Grok? And these learning how to interact with AI is not unlike being someone who is really good at asking questions. You're incredibly good at asking questions, and prompting AI is very, very similar. You can't just randomly ask a bunch of questions, and so asking AI to be an assistant to you requires some expertise and artistry in how to prompt it. And so if I were a student today, irrespective of whether it's for math or for science or chemistry or biology, or it doesn't matter what field of science I'm going to go into or what profession I am, I'm going to ask myself, how can I use AI to do my job better? If I want to be a lawyer, how can I use AI to be a better lawyer? If I want to be a better doctor, how can I use AI to be a better doctor? If I want to be a chemist, how do I use AI to be a better chemist? If I want to be a biologist, how do I use AI to be a better biologist? That question should be persistent across everybody. And just as my generation grew up as the first generation that has to ask ourselves, how can we use computers to do our jobs better?
Yeah.
The generation before us had no computers. My generation was the first generation that had to ask the question, how do I use computers to do my job better? Remember, I came into the industry before Windows 95. Right? 1984, there were no computers in offices. And after that, shortly after that, computers started to emerge. And so we had to ask ourselves, how do we use computers to do our jobs better? The next generation doesn't have to ask that question, but it has to ask, obviously, next question, how can I use AI to do my job better? That is start and finish, I think, for everybody.
It's a really exciting and scary and therefore worthwhile question, I think, for everyone.
I think it's going to be incredibly fun. AI is obviously a word that people are just learning now, but it's just, it's made your computer so much more accessible. It is easier to prompt ChatGPT to ask it anything you like than to go do the research yourself. And so we've lowered the barrier of understanding. We've lowered the barrier of knowledge. We've lowered the barrier of intelligence. And everybody really ought to just go try it. The thing that's really, really crazy is if I put a computer in front of somebody and they've never used a computer, there is no chance they're going to learn that computer in a day. There's just no chance. Somebody really has to show it to you. And yet with ChatGPT, if you don't know how to use it, all you have to do is type in, I don't know how to use ChatGPT, tell me. And it would come back and give you some examples. And so that's the amazing thing. The amazing thing about intelligence is it'll help you along the way and make you superhuman, along the way.
All right, I have one more question if you have a second. This is not something that I plan to ask you, but on the way here, I'm a little bit afraid of planes, which is not my most reasonable quality. And the flight here was a little bit bumpy, very bumpy. And I'm sitting there and it's moving and I'm thinking about what they're going to say at my funeral. And after...
She asked good questions. That's what the tombstone's going to say.
I hope so.
Yeah.
And after I loved my husband and my friends and my family, the thing that I hoped that they would talk about was optimism. I hope that they would recognize what I'm trying to do here. And I'm very curious for you. You've been doing this a long time. It feels like there's so much that you've described in this vision ahead. What would the theme be that you would want people to say about what you're trying to do?
Very simply, they made an extraordinary impact. And I think that we're fortunate because of some core beliefs a long time ago and sticking with those core beliefs and building upon them. We found ourselves today being one of the many most important and consequential technology companies in the world and potentially ever. And so we take that responsibility very seriously. We work hard to make sure that the capabilities that we've created are available to large companies as well as individual researchers and developers across every field of science, no matter profitable or not, big or small, famous or otherwise. And it's because of this understanding of the consequential work that we're doing and the potential impact it has on so many people that we want to make this capability as pervasively as possible. And I do think that when we look back in a few years, and I do hope that what the next generation realized is, as they first of all, they're going to know us because of all the gaming technology we create. I do think that we'll look back and the whole field of digital biology and life sciences has been transformed. Our whole understanding of material sciences has completely been revolutionized. That robots are helping us do dangerous and mundane things all over the place. That if you wanted to drive, you can drive, but otherwise, take a nap or enjoy your car like it's a home theater of yours. Read from work to home, and at that point, you're hoping that you live far away, and so you can be in a car for longer. And you look back and you realize that there's a company almost at the epicenter of all of that, and happens to be the company that you grew up playing games with. And I hope that to be what the next generation learn.
Thank you so much for your time.
I enjoyed it. Thank you.
I'm glad.